will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too hard. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Aren't you guys sick of me already? Come on. You don't have to stick around, alright? You don't have to watch. You guys can go do something else, alright? Now, thank you guys for being back for another day of epicness, alright? We're getting more into Unix, finishing this shit up, finally. Holy crap. So much. Alright, if you're new and joining us, well, hello. It's nice to have you there. Now, if I can bring up, if you didn't know, we are Rootkit, a non-profit. We want to be your tax haven. Donate to us. If you don't have money, it's alright. Go to our site, alright? Go to our site here, and you can check out, we have our week 5 giveaway. We're giving away another amazing sweater. Doesn't require any money, alright? You just come on here, subscribe, various other basic tasks, and you can win yourself one of the amazing sweaters we have. If you do have cash and you are serious about having us become your tax haven, alright? Send us your money. We need money. Doing stuff for free is not cheap, alright? And it can't last forever, alright? It is only possible due to generous donors. If we have no generous donors, then we can't do things for free anymore. So please, if you're enjoying what we're doing, send a donation over. And in response, there are rewards that you can get, like stickers, this amazing shirt I got right here. Look at this. And our awesome sweater. And the answer to the shirt question is, yes, I have washed it once since we've started, right? I have washed it once, but it's been a little bit, right? It's starting to smell a little bit. It's all right. It's the programming way, right? You gotta not bathe except once every month. If you're not doing that, are you really unlocking your true potential? I don't know. We'll see. But what do I got here? Yeah, donate. We got awesome pillar things that will happen, like 24 hours straight streaming, shaving my head, and the one that we don't need to get to, all right, which is cutting this beard off. No one wants to see that, so we won't even worry about that one, all right? So let us continue on, shall we? If you want to follow us, hey, guess what? We have everything posted for free online, listed that you need to know in order to get our exam, the Comp Sci Cert, the complete replacement to a college degree. If you get it, we can get you a job. All right, get it, and we'll handle the rest for you. We left off in operating systems, so if you go over to our GitHub, you can see the Comp Sci, and you can click on it and see we've bullet pointed everything you need to know in order to pass the exam. If we scroll down on this, you'll see that we are currently in the Unix section. Woo! So this is for all Unix-like operating systems, which most predominantly is, is Linux. All right. Now let's see here. We've been learning a lot of stuff. Hopefully you guys took time to practice. We chatted about practicing on Sunday and how it's important and how you guys should just, you know, use these depending on your operating system and what you have access to. Use them to make files, create files, delete files, edit files. Just a bunch of moving around, you know, run the commands, test them out, see what you can do, you know, maybe show your mom, your dad, brother, sister, significant other how much of a hacksaw you are, all right? Because hey, you're doing all the things that people in the movies do. It's pretty cool, right? Except now you know the secret. You're pretty much ruining yourself for all those fancy movies from now on. You're gonna see them do the things that we've covered on here, and then you're gonna be like, I know what that does. That doesn't make any sense. How did running the ls command hack them? I don't know. Movie logic. What can I say? Alrighty. Let me double check the chat here. If you guys have any questions, I like it. Delusions or decisions. God, I'm delusional. I can't even read. All right. If you guys do have any questions, just feel free to post them in the chat at any time, and I'll be checking periodically to make sure I'm not missing anyone. And I am in the event chat inside of Discord, so if you are a Patreon member or a Discord premium member, then you can get access to the events chat. Join in here and chat away. just verbally. All right, you don't have to type. All right, typing is too difficult sometimes. I know it's too difficult for me a lot of the times. All right. All right, let's see here. I did see that one of you guys did currently become a Patreon member, so thank you so much, Marvin, for that. Super epic, super epic. Let me see if I can rerun the alert on it. Oh, look at that. Thank you so much. Alrighty, let's see here. Unix. We gotta finish up. Alright, we gotta finish up with our Unix stuff. Let's go ahead and launch Ubuntu, and you can launch your stuff however you want. I want terminal. Thank you very much, because it looks prettier, and the settings are already borked on here, so it's super big for the stream. Perfect. Alrighty, let's keep working on down through this massive list here. So we talked about getting more head and less tail. All right, goal for a lot of us this year. And we talked about how, you know, you can get really intimate with your computer in Linux land. You can touch it and it will respond to your touches. You can say hello to the cat that's pre-built in. Pretty awesome. You can say echo like you're in a canyon, except the computer will also do what a canyon does. It will echo it back to you and print it out on the screen. Very neat, very neat. And we finish up with ping, netstat, tracer-t. Some of these items may require additional package installs. It's just a way, usually it's not included in the operating system. If it's more of a consumer grade operating system, which Ubuntu desktop is more of consumer grade, so consumers don't usually use those tools. So in order to make the operating system more lightweight, they just don't include them. Let us move on here. So we talked about touching, McDirs, copying, moving, and let's see, LN. So remember, man is how you get the manual page. LN is going to be how we're going to make links between files. So on Windows, you might be more accustomed to this if you, let me go and show it off. If I open this up and we go to desktop, all right, don't look in this folder, right? If we want to make a link to something, we could right click it on Windows, and there should be a button here for create a shortcut. All right, this shortcut is a link, and it even shows that little icon here. It might be a little hard for you guys to see, but a little icon here with an arrow. That means that this isn't the actual file, this is a link to the file. So when you double click on this, it will actually link up and grab the file from elsewhere. You can do the same thing here in the command line using the ln command, all right? So you can see it's the target and then the link name that you want to give. So super awesome, super neat that way. So we do ls, let's say, what file in here do we want? Is there lightning? That was weird. So let's put some contents in one of these files. Now, I'm going to do this real quick. Don't worry, we're going to revisit. Actually, let's just talk about it now since we have to make some contents in a file. So we're going to go ahead and remove some of these files because it's kind of getting cluttered here. So if we do rm, and now we can go about this a couple ways. All right, you can say rm to remove things, and we can remove things like file2 and nothing printed out, which means silence is good. We want silence. So if we do an ls now, you'll see that that file 2 is no longer here. It's gone. It's been deleted. All right, so that's pretty neat. Something else you can do is use that wildcard, that asterisk. That asterisk we talked about will fit a lot of things. It will match a lot of stuff. You can use the asterisk by itself and it will match everything, or you can use it at the end of files. For example, if we want, let's see here. We got my new file and my new file 2. We want to delete both of these, but again, we're programmers. Programmers like to be lazy. We don't want to keep typing a bunch of stuff. We want to do it as quickly as possible, all right? So what we can do, instead of saying my new file 1 and then my new file 2 and deleting them each by each, we can instead put anywhere in here, whenever we deem it unique enough, we can put an asterisk. All right, and the asterisk will delete everything that matches that moving forward. So if we do an ls now, you'll see that both of these files got deleted, because what's going here is it's a wildcard. So it's going to look for anything with my new, and then it sees the asterisk, which means that anything with anything after my new needs to be deleted. So it's an autofill, autofill, autocorrect, however you want to put it. It will automatically try to complete and fill out and delete every file that has this prefix. All right, be careful. Be careful with this. If you're doing this on your computer, be careful on what you're deleting. All right, make sure you have enough in here in order to specify just the files you want. Because if I were to do something like remove asterisk and run that, you're gonna see it removed everything. All right, so you might not want to remove everything, so make sure you're being specific enough so you don't accidentally remove everything. Now rim will not remove directories by default. You can either use a tac command for that, or you can use the command rimdir. All right, we got a rimdir, and then you can choose mycooldir, and it's not empty. So by default, directories will not be deleted if they are empty. You'll have to do additional commands for that. So if you ever get this error and you get angry at your computer, make sure you consult the manual for the command, all right? And that will tell you usually what you want to do. So let's go ahead and look at the manual for rimdir. All right, so we can put some options here at the beginning and then the directory at the end. So let's see if there's anything in here for forcefully removing all the contents inside. So removes directory and its ancestors. I'm pretty sure. Wow, that's rough, man. You really want to remove something, you gotta take out all of its ancestors too. Talk about deleting. Let's move on here. Doesn't look like we have anything else here that will help us. So if that is the case, Google is your best friend, all right? Google is your best friend. You can go out searching the interwebs, or you can give up and just delete all the contents inside of this directory. But what if, let's say that directory has like 20 more directories in it with a bunch more files like stacked on top of each other. That's gonna be cancerous. So let's go ahead and consult the normal rim command and see if there's anything in here that might help alleviate our issue. All right, remove unlink the files. So we have a tech F for forcing, so ignore non-existent files and arguments. Interesting. Prompt once before removing. Interactive. Prompt before every removal. So this might be, if you're doing that asterisk, you may want to use this in order to get a prompt that's basically asking you like, sure you want to remove it? Let's go ahead and, R is recursive. Remove directories and their contents recursively. Interesting. This may solve our potential issue here. All right. So looking over the manual can be very, very powerful for you. You can also Google things if you don't initially see them in there. So we know we want to delete directories, and one of our directories have contents in them, and this will do that. Perfect. It solves our solution. So let's go ahead and do rim and then tac R for the recursive, and then we can do our folder, so mycooldir, and no message means everything worked. So let's go ahead and do an ls, and this directory is now completely empty. Sweet, 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 sweet. So again, going over how you will, investigate and figure out potential issues that you're running into. Just take step by step, consult the manual, just like you would ideally for anything that you're looking into. I mean, I'm pretty sure most of us just, open a new box and throw the manual to the side and just try to piece things together. You can do it. It's all right. But just keep it handy, keep it close by. You may need it, all right? Especially in the computer space. There's a lot of stuff going on here, and a manual is handy every once in a while. Alrighty. So let's see what to go over here next. Okay, we want to do linking. So we want to make a file. We can use touch to make a file. All right, so we'll go ahead and do touch my cool file. All right, so we've made a file. But if we use cat, because we like cats, and that will be to print out everything onto the command line, we'll see that there's nothing in that file. So we need to add some contents to that file. So in Linux, pretty much every operating system will have a text editor built into it, just kind of like how Windows does. And that editor will be called Vi or Vim. VI or Vim, however they want to call it. It's a cancer editor. I absolutely hate it. Some people absolutely love it. It has a cult following. We're going to tolerate it and talk about it because it is built into everything, so you need to know how to use it because you can usually depend on it being there. I prefer Nano myself, mostly because if I'm doing stuff on the command line like text editing, I don't want to be there very long. Text editing on a command line is cancerous, all right? Maybe you like doing text editing on a command line. Maybe you'll be one of those weirdos that like Vim and use it religiously. Hey, it's all right. I'll still make fun of you for it. It's okay though. You do you. All right, so in your editor, you can do VI or Vim. And when you do that, you'll usually get this prompt that comes up. This is going to be your editor. And I'm going to quit out of this. We got to talk about it a little bit. This is pre-built. I don't think we include Nano on here, but there's another editor called Nano, which is not included in all distros. All right, so don't depend on this. Do not use this one because it may not be there. But Nano is a little nicer. As you can see, this one a little nicer. You can kind of understand what's going on here. But we ought to talk about Vim. All right, so see, VI works. Also, Vim works. So how do we go around messing with files? So you can use this to edit an existing file or create a brand new file. So we have an existing file that we want to edit. So what we'll do is we'll type in Vim and then we'll do my cool file and press enter. Now we're editing, and you can see right here, my cool, oh no, what have I done? My cool file. Let me quit out of this and rerun it. My cool file. And it will give you some additional info at the bottom about which line you're on, how many characters you are over, etc., etc. Anything that's a tilde here in blue, if you have color coding going on, not everyone will have color coding going on, means that this is not a part of the file. It's completely empty. So Vim has two different modes to it. One will be the insert mode, where you can then insert text to it, and the other one will be, what's the term for it? The command mode, where you can usher in commands to the Vim editor. So while we're in here, you'll notice if you start typing characters, so I'm literally, look, I'm typing characters. You guys hear that? Nothing's happening, all right? You'll see some of the characters kind of show up here. Nothing is going to happen, because you can't just edit files right off the bat in Vim, all right? You have to press I. The I key will now allow you to edit insert mode. It will allow you to enter insert mode, right? And now you can edit and type and add contents to your file. As you can see here, this is going to tell us which line we're on, and this is which column, so how many spaces over. So if I do space, you'll see another thing. If I type in a character, it moves over a little bit. All right, we can press enter and go to a new line and add new stuff, and we can basically make our cool new file. We can make our cool new file here. Awesome. Now how do we save it? Great question. If you want to leave editor mode, insert mode, whatever you want to call it, it's properly insert, all right? You have to press escape. You have to escape out of it. So when you press escape, you'll see here, watch real close, insert will go away, Bam, it went away. We're no longer in insert mode. All right, now we can usher commands to Vim. There's a lot of pre-built stuff for Vim. It is pretty powerful out of the box. I will give it that. The only thing is, it's a steep learning curve at first. Nothing is really known to you. No prompts are really given. You have to spend time learning and figuring out. The only things I need you guys to know is that pressing I will get you into insert mode, which is where you can start editing files. When in there, you can press escape to escape insert mode. Once you're escaped from insert mode, now you can usher in commands. All right. Now the command that we want to do, we have to initialize it by doing a colon. All right. So type in colon, and now we can usher in some commands. The typing in an S here and pressing enter will save. So if we do that, that will save. No previous substitute regular expression. Sorry, W. My bad. I'm a little confused right now. W will write to the file. It will write your new contents. All right, it's brain fart moment there. All right, W will write. So you'll see that our file, we have just written to it. Even says written right here. All right, 48 bytes of information we have written to the file. All right, awesome. So when you do that, you'll still be in command mode. We can write it again if you want. If we do colon W and press enter, that is how we can again save. Any questions on that before we move forward? Go ahead and drop them in. Now, if we want to quit, we have to do colon and Q. All right, and that will quit it. Awesome. You can also stack these commands on top of each other. So a common stacking of commands that people will do is when they're in command mode, they'll do colon WQ for writing and then quitting. So when we press this, we'll automatically write and save the data we just typed, and we'll quit back to the editor. Some people, like me, will always do WQ bang, which is for forcefully, so it will save and then try to quit, and the bang will forcefully make sure you quit. Because sometimes it may bring up some prompts or ask you if you're sure or not, etc., etc. And now if we type in cat again, we can see and confirm that our information is now in that file. So we actually put text into that file. Any questions so far? This was a lot. Very particular. So again, Vim or VI, depending on what OS you're on, they may have one or the other. VI typically will always be available. Then after that, you need to say the file you want to edit. You can also put in a name of a file that does not exist. So let's say this file doesn't exist. All right, this file does not exist. We did not touch and create this file, but we can use VI or Vim to make this file. So you can see this is a brand new file that we are creating right now. If we said, oh, never mind, I mistyped something in here, I need to go back and fix it. If we do W and Q immediately and do an LS, you'll see the file is not there. The file will not get created unless we write, unless we save, all right? We gotta usher that W command first. So if we rerun this and press I, again, the first thing I do is press I to enter insert mode. I fat fingered K there also afterwards. Then we can add our new information. Adding new info. So cool. All right. After we're done inserting new info, we can press escape. Now we've escaped and we're back into the mode where we can usher in commands. We'll do a colon. We need to write this new file. And once we write it, we can just go ahead and quit the application. So we can do quit right afterwards. And press enter. We've written it. It's quit. If we do an ls, you can see that file is now there. It now does exist. And if we do cat, this file doesn't exist. You can see our info is in there. Super, super awesome. All right. hopefully that's not too difficult for you. It's a little bit weird, especially when, you know, Windows comparison, like Windows version of this is Notepad, and Notepad's a little bit easier to use for someone brand new, but trust me, you'll prefer this way a little bit better as we move forward. All right, any questions? Drop your questions if you have questions. Now, again, mess with this. Do it. Accidentally mess up and think you're in insert mode when you're in the command mode, or vice versa, all right? Mess around with it. It's okay. Break things. Try to break it. See what happens. That's the only way you can really like easily memorize this stuff. You can always, you know, memorize it by watching the screen, making flashcards, etc. It's going to be way easier if you just sit there and do it yourself, all right? Promise you. And there's no way to get around this. There will be times where you're going to have to use this editor. Now, I'm pretty sure it's not on the test, but there's also Nano, which I usually will use if it's available. Nano, it works the same way. You say Nano in like My Cool File, and you press enter, and you get a little bit more of a pretty GUI. You can immediately start editing your file. You can just move around. Nothing crazy you have to do. All right, it's kind of more similar to a normal text editor that you're used to. Like I can just go down here and type in stuff. All right, super easy. And then at the bottom they have a little help menu that tells you what to do. This caret sign here is the control key on your keyboard. All right, so if you see this sign, it means you need to press control and something else at the same time. So if we want to save, saving is going to be writing out to the file. So if we want to save, we have to press Control and O at the same time. And when we do that, you'll see this prompt comes up and it will say file name to write to. So this is the file that we opened, so it will write to that one. We could also change the name in here if we wanted to something else, but we're gonna keep it the same. And we just press enter. And now we've written to the file. All right, and then if we want to exit, we can do Control X. Right here it says for exit, Control X. So Control X, bam, we have exited. So that is also available. For sure, we don't have anything in regards to that one on the test because it's not in a lot of operating systems by default. VI will be there. So you can count on that. You can count on it so much that most of the automation stuff that's done in programming will be done utilizing the VI editor to blink around. We'll use the VI editor because it is consistent. It's usually always there. All right. Any questions on that? Let me double check here. So now that we've made some files here with text in them, we can move forward with linking just so we can see it more visual. So let's go ahead and check. So we got ln, and if we look at that again, ln requires two things after it. All right, it requires the target, so what we want to link to, and then in our actual link's name, so what we want the link to be called. So if we go in here and we say ln, let's go ahead and make a link to my cool file, and let's call this link my cool link. And nothing printed out, which means it was successful. If we do an ls, you can see my cool link was put here. Now, to get more information about this and see it more visually clearly that this is a link, we can usher in ls with all the options Lisa. All right, your good friend Lisa, let's bring her into this party so she can help give us clarification on what's going on. And if we press enter here, we can see Lisa has done a good job once again in giving us a bunch of information here. And we can go through and see in here all of the different files that we have. In particular, we got our link here, which is not showing up as a link, so I'm partially confused. So let's go ahead and check that out and see what's going on. It looks more so like it made a copy, but maybe that's the default behavior for things that are, what do you call it? My cool link. for things that aren't folders. All right. So one way we can just double check to make sure it actually is a link. This link links to that file. So right now, if we print out the link's contents, it is hooked up to my cool file. But if we delete my cool file, my cool link should now not print anything, if not mess up. And it does print stuff. All right, then let's double check the manual here. Make links between files, target, link name. In the first form, create a link to the target with the link name. In second form, create a link to target in the current directory. In the third form, let's see here, ls Lisa. And this stuff just ain't panning out how I expect it to right now. Link directory, logical, differentiate the target. Am I supposed to do the tech-l command for the logical link? I think so. Let me pull up my notes here and consult the helm. All right. Where would you be in my notes? Where would you be? Singing always helps. Let's go ahead while my notes load up here because they're taking a while. Let's go ahead and try this again with this file does not exist. With the tech-l, this file does not exist. My link. All right, let's do a capital L for the logical link. What have I done? And ls, let's bring in Lisa here. Help me out, Lisa. No bueno. Where is, all right, Control F, LN. Here we go. That's, oh my God. Sometimes I get mad at myself. All right, let's see here real quick. LN tag S. My link. Whoops. This file does not exist, and we're gonna call this ASDF. There we go. Now we got the color coding going on. And if we bring in Lisa here, she'll confirm that this is a link. ASDF is a link to this file does not exist. All right. Whew. I was sweating there for a little bit. I knew I was forgetting something. So S is how you can make a symbolic link. All right. So that's what we were trying to do originally, is make a symbolic link. Before it was just making a copy of both of the files. And I know it's saying it creates a link there, but it's kind of incorrect. So we wanted to make a symbolic link, which is the shortcuts that I showed. It's going to be here as the tag S command for symbolic link, and it also mentions it here towards the bottom. All right. So tag S is for your symbolic links, and that's where we see. Let's bring in Lisa in here to this party, and that's where you'll see these ones come into play, which these are going to be our symbolic links. All right. Those are the ones we're trying to create. You can make the normal hardcore links, which I can't remember the exact differences between the two. All we're going to test you guys on is that, do you know what the ln command can do? And we will specifically test on the tag S, making symbolic links, all right? Because that's what you'll typically be doing when you usher in the ln command, is making the symbolic links. All right. So again, let's go ahead and rim everything. All right. So asterisk for removing everything. Let's go ahead and remove everything, and let's rerun through this again, shall we? Let's make a new file. We don't have to use touch, right? We can use Vim. So let's type in Vim, and let's call this hot dog. All right, hot dog is our new file. When we type in that command, we are in Vim. We need to get into insert mode so we can insert text. So we gotta press I first for insert mode. Once we do that, Visually, you'll know if you're in insert mode by looking right here and you'll see the words insert. Then we can go and type away. Hello, I'm in insert mode. All right, awesome. To escape insert mode, we press escape. So let's press escape and you'll visually see the word insert will disappear. All right. Now when we're here to save, we need to do a W for writing the information, writing out the information. And to quit, we will need to do Q to quit out. So you can run them individually or you can stack them on top of each other. W will write, I'm going to run that by itself, and you'll see we have written, it has information down below that it wrote the information out. Oh God. Then if we do colon and then Q, you'll see that we will now quit, and we have quit. Awesome. And to confirm that everything was successful, we can run cat, hot dog, press enter, and you'll see the text is there. Awesome. Now, if we want to ever link to a file or directory, we can use the ln command, and to make a symbolic link, you have to do tac s, right, to make the symbolic link. So we can say link to my hot dog. I guess before that, we have to actually put the file that we want to link to, which we want to link to the hot dog. So link symbolically to the hot dog file, and I want my link to be called, oh no, what have I done? Link to my hot dog, all right? And if we press enter, nothing significant printed out, so we know we were successful. So if we bring in Lisa to the party, she'll tell us that everything's good, it was made, and it's pointing to our hot dog here, all right? Now, if we cat link to my hot dog, you'll see it prints out the contents. But if for some reason we deleted the original file, so I removed hot dog there, and we tried to print out the link to my hot dog again, it will say that no such file or directory exists. All right, it was deleted, so now the link is broken. So be aware of that. Any questions on that so far? Pull up the chat here. I see no questions so far. If you do have any, go and drop them in there, and we're gonna go and continue forward. Alrighty, we have grep. So let's go ahead and do a man on grep, and not greppo, grep. So grep is for printing out lines that match a certain pattern. So this is going to be for finding stuff, right? It will be for searching through and trying to find some certain information that you need to find. It follows some type of pattern that you need to give. So if you look through here in the manual, you can see some of the patterns that you're able to give and have it look for. All right, this may be different for what exactly you're doing. Grep can be pretty crazy with what you can do. A lot of people do some really crazy stuff. It can be used pretty simply though if you want to use it simply. So let's go ahead and delete our link here, and let's make a new file. So let's load up Vim and say grep me please. All right, so let's go ahead and press I to get into insert mode, and let's go ahead and put some text in here that we want to search for. So hot dog, pizza, spaghetti. All right, I don't know, avocado. I feel like this is a spelling quiz for me. All right, let's see here. We need some other items here. Put some items in the chat if you want to see me put something on here. I don't know what's around here. Rice, bacon, pineapple, and banana. All right, sweet. We got our file here. Let's go ahead and press escape to escape insert mode. All right, we're gonna do a colon and WQ. Again, W for writing out, Q for quitting. We can combine those together. Make sure they're in the right order, because if you do Q first and W after, you're going to quit the program and you're not going to save your information. Don't do that. That won't be fun for you. You're going to have to go back and retype everything. All right. So we have this. If we want to confirm, we can do cat grep me please. And we can see that everything is Gucci. All right. So let's look back into grep, because let's say we want to find rice, right? We want to find rice in there. So print lines that match the pattern. So we got to do the pattern first, and then it looks like the file after. All right. So file of blank stands for standard input. So I believe we have to use standard input for this. We'll see here in a second. Alrighty, so we want to do grep, and we want to find, let's say, rice inside of grep me please, and bam, that worked. It found rice inside of this file. Alright, again, the pattern was grep, what we want to find, so the pattern that you're trying to look for, and then the file, or you can use standard output for it, or input. We'll get into that in a second. So it found it, and you can use grep to find to output more information, like what line it was found on, etc., etc. If you look through the manual for it, you can find all of that good information out. If we try to look for something that's not in there, you'll see that in this case, when it doesn't find anything, it will not print anything out. All right. So failure is nothing. This is an oddity in the space. Usually failure will always print something out, but that's what makes kind of grep useful in a lot of ways because of that feature. And it's mostly when you compound grep onto other functions and functionalities, like using pipe, and you'll see as we move forward. Alrighty. Let me make sure there's no questions that have rolled along. All right. So again, if you want to look for more information here in regards to the output and how you want the output be, you can go ahead and look through there. There is another way you can do finding, and that's using the find command. So if we do man find, you can see you can search for files in a directory hierarchy. So this is for specifically finding files and where they're located in the operating system. All right. This can be very useful for you for finding things, and then especially when you compound it with grep, you can find like certain files with certain types of text or context inside of them. And I think in find also it does allow, maybe I'm converting it for something else. Maybe it's this. You can search for certain types of pattern of file names. Now you'll notice something different about these types of operating systems compared to Windows that we haven't really talked about too much so far. All right, before moving forward, and before we get into find, you'll notice that even here, there's something missing in all these file names. If we go to our root directory and we go into, I don't know, bin, and we do ls, you'll notice that something's missing for all of these files. Something major that Windows will always have. And as for comparison, let's go ahead and we can just go to PowerShell right here. We need a bigger PowerShell. Let me pull up the other one, the massive one. All right. All right. All right. Let's see here. Let's look at files here. Particularly, let's go to our system 30, or yeah, hold on. Let's go to root directory. We want to go to Windows, and then system 32. System 32. All right. When I do ls here, there's a lot of files. Ignore them being a lot of files, but there is something unique in here. Okay, I'm gonna quit this. This is taking a long time. There is something in here that is different than these ones, particularly in the file name. Have you guys noticed it? Big difference, all right? So this is the big difference between there are several differences between the Windows and Linux operating systems or Unix-like operating systems. One, spaces. No spaces. All right, do not have spaces in your name, and it's honestly best practice for you never to have spaces in the names of your stuff on the Windows side either. All right, because it just complicates things, and you lose a lot of compatibility with things like Linux machines. All right, don't use spaces overall, but you definitely don't want to over in this land because things will not work for you. All right. Number two, you'll see the little extensions at the end, right? The extensions that tell you what the file is. Windows requires these in order for something to run properly, because Windows uses this to identify what a file is, what is its function, all right? Why does it exist in the first place? It uses that as the cue, as the major indicator. If you change .exe to something else, the Windows operating system will freak out. It will not know what to do. If you change it to .txt, it will open it as a text file, all right? The end here, all right, your postfix, your extension is all about you dictating and telling the operating system what that is. In Linux, that's not a thing. You do not dictate it that way at all. Instead, there are bytecodes at the beginning of each file. So bytecodes are just things that are in binary, and it's going to dictate what the file is. It will tell the OS what that file is. So in particularly, we do strings, strings, and it should show up here, right? Holy crap. Let's do strings, let's see, MV, trying to pull up an example here for you guys real quick. All right, so for example, we got our little header right here. So this is, so hex dump is how to print out the binary information of a file. So this could be a text file, a binary, something, anything. It will print out the binary data. This is going to be essentially your line numbers, all right? And then this is going to be the actual data. So you'll see here there's some information, and this information here at the beginning, I believe it's the first bytes, 2 bytes, 3 bytes. Let me see here. Let me look this up. Let me see. Linux byte code length. All right. Well, is it 64 bits? I can't remember exactly right now, but it's either this column or these two columns, but that will dictate what the actual file is, and that's what it uses as reference to know how to execute that file. All right, so this needs to be set properly in order for Linux to go about executing it properly. All right, if we go back to our home directory and we run the same command here on our text file, you'll see it has a completely different one. All right, now if we go back into the bin directory, whoops. If we go back into our bin directory and we even analyze more stuff, like, I don't know, the cd command, you'll see that it is CD not in here. Let's look at something else like nano. You'll see, yeah, okay, sorry, it's the first, what is this? 1, 2, 3, 4. 4 bytes, right? First 4 bytes of information will be the signature of the file, all right? And as you can see, this is exactly the same as the move command, and that's the indication that it's going to be an executable, all right? This will vary file to file, all right? So just something to be aware of. Extensions are not required in Linux. You do not need them. They are there visually to help you out. If you ever see them, they are there not because they are required. They are there because it just helps you visually understand things. Because if you just see a bunch of files that are listed, it may be confusing on what is a text file and what is not. So for example, if we go to Etsy, again, Etsy is everything that's configurable. So these are where your configuration files will be for services. You can see some of them will say .conf, not because it's required, but because it gives a logical understanding of what that file is. Some other people will just put config in the file's name, and some other people will just not do anything at all. It's totally the Wild West, and it's totally up to you on how you want to go about it, but the end result is that it's not required. So something you guys need to be aware of when you're on these types of boxes. All right, let's go here. Let's bring up our terminal and find. All right, so let's go ahead and try to find, let's do a new file. Let's make a directory called don't look in here. And let's go and cd into don't look in here, and let's go ahead and touch you found me. All right, sweet. So we made all of that stuff. All right, sweet. So now let's try to find this file. So in the find command, let's go and look at the manual again. You can search for files in a directory hierarchy. All right, so you can search pretty much anywhere you want. The only things you really need to give it is what you're trying to find, and then the starting point of where you want to find stuff. Please, for the love of God, give it a starting point, unless you want to search your whole entire operating system. If you do that, it could take a very long time. So we want to definitely give it a starting point here. So we want to give it a starting point, and we want to give it an expression to for what file to find. All right, the expression could be multitudes of different things. We're going to use it in the most simplest form, which is where we just give it a file name and we want it to find that file. All right, you can get fancy with it. There's lots of options here that you are free to look through and figure out how you can get really fancy with it. All right, so we want to search. Let's go, let's search right here. So we want to find inside, so this is our starting folder. We want to start in QFC9, and we want to find the file you found me. All right, if we press enter, you can see that it started going, it started searching. See, there were some questions in here. Do we start? No, you do not type in starting point. You just type in like what you want the starting point to be. So as you can see here from our output, there's a lot of default functionality in find that could be cool, or it could be really, really annoying, depending on how you want to take it. All right. So first off, it will visually print out by default where it is searching and what it is looking for. So you can see it was looking in the QFC9 folder and trying to search for that file. All right, we can visually see everything that was going on, and it looks like here is our file, and it was unable to find it because it says here at the bottom, it gave us a little error that said no such file or directory exists. So even though it did find it, and I didn't do a typo, right? Yep. Even though it did find it, that's not the default functionality. So you may need to adjust your search in order for, oh, thank you so much for the follow, X Stories. So you may need to adjust your search by either looking at the manual, or maybe doing other things like maybe adding asterisks or etc. to find what you're looking for. All right, so it's not giving us what we want right here, so no such file exists. So we know we're doing the command half right. So let's go ahead and take a look at the find command again to see what we might be missing, right? So it's important that you do look through the manual or you do some Googling, because sometimes things in the computer science realm are kind of deceptive. They aren't as easy as they may seem at first. So let me go ahead and pull up my notes here so we don't have to read through everything. So they want, let me see here, where is it at? I think it's towards the bottom. So you can use regex for these. We'll talk more about regex when we get into the computer part of stuff. And there we go. So this is where we need to specify in regards to the expression. Typically you need to also tell it and give it the option of what expression format are you using. All right, so that is our missing piece right now on what we need to do. So we need to choose a pattern from here on what exactly we want to utilize. So let's go ahead and see here. We got name. All right, this is the most simplistic one. We just give it a name. So let's utilize this pattern. So let's rerun this command and do tac name. There we go. That one worked. So again, sometimes commands are a little deceiving. If you do one of them and it doesn't work at first, you can punch your computer in retaliation. That's normal, right? There's lots of holes in all of my monitors, all right? But once you do that, after you do that, then you can go reading the man page, or you can go search around in Google to try to find these answers. Because not everything, again, is what it seems at first. Is this bad design? Yes. Yes, it is. But again, remember, a lot of these tools are really, really old. They were made back in the 80s, and they made sense back then. There may be purpose behind the default behavior of these, all right? They're usually, hopefully, we hope for that there was actual purpose and intent in setting them up the way they are, all right? So how you could have figured this out to begin with. The keywords to look for, like things like expression, it's not file name, it's expression. All right, so that's and it's also an optional thing, so that's something to look out for, and it should set off, you should look for that as and keep it in your head as a red flag, as an indication of might need to do some more work. Again, also reading the description may be helpful. All right, but there you go. So tac name is the expression we want to be using, and that's how we can find that file. All right, and again, you can do your starting place anywhere you want. Let me see if I can, there we go. I did it in the root directory this time. So you can see when you do it higher up, it will automatically run. The default behavior for it is to automatically run forever until it goes through all of the files and will find every single result. So there are options that you can use and utilize to have it stop after the first result is found. All right. The default behavior is keep searching, and you can see it's still searching for more results. So I'm going to stop. Again, this also is based off your perm level. We're a normal user, we're not an admin. So when this tries to look at admin files. Only like things that an administrator can look at will also get printouts of errors. So make sure you're not searching in areas that you're not supposed to be, so you can avoid getting these errors printed out and messing up your output. Any questions on that? I don't see any questions currently. All right. Let us move forward. Witch. Now it's time to go on witch hunts. All right. Not really. Different type of witch. Witch. Witch is a nice command. It can be very clutch at times depending on what you're trying to do and what you're trying to solve. It's literally just called witch, not like a witch hunt witch or a casting spells witch, even though it could be that because it kind of works magically, but a witch on like which one is which. All right. Now, if we look at the man page of witch, it is a simplistic command. There's not too much that you can do with it. As you can see, you only have one option, and that's the tac A. So what this will do is it will locate where a command is found exactly. So what does that mean? I install an application. How do you make the look at me folder? We'll go over that here and after I finish this. So which this is how you can locate where a certain program is installed on your operating system. For example, it's kind of a pain in the ass on Windows to figure out where something is installed. The typical way is you'll find, I don't know what you're trying to look for. Maybe it's like Chrome. I got Chrome right here. And you can right click it and look at the properties. And then on here, it will give you the rundown, basically starts in. This is where it is. And then up here for target is more specifically which executable is running when you click on it. All right. So witch does the same thing, but it's a little bit easier and nicer. We don't have to go on a little witch hunt per se on Windows for it. So if you installed a new game or something and you didn't know where it was and you wanted to mod it, this may be very, very useful. All you do is you say witch, and for example, let's do ls. This will tell me where ls is currently located. If I do something like cd, this will tell me where it's not located. If we do something like find, that will tell me where it's located, and etc, etc. It will tell you where that command is actually located, right? Very, very convenient. That's pretty much all to it. All right, in regards to how do you make the look at me folder, you're going to want to do mkdir. That's for making directories, mkdir. All right, so let's see here. We got file. So file will help you determine the file type. It's, let me see. Oh, whoops. Scroll down here a little bit. Does it have, looking for something specific. Let me pull up my notes. That is not my notes. Also, so you guys know, if you, I know I got really bright there for a second. All of the man pages are available on the man7.org website. So if you don't want to read in the terminal, you can read on the site. They should be exactly the same, the most up-to-date man pages. And you can search for them. There's also a list of them all here. So there are a lot of them here. All right. Now, not all of these are going to be commands you can run on the command line. Some of these are going to be C functionality, C/C++ command line functionality. That's pre-built into Linux because it's great to have the whole manual for the C programming language included in the operating system with you So it's just a convenience thing. So that's very, very nice, and you can dictate what it is based off these numbers right here. So you see the number 3. So you can basically have multiple names of the exact same man page, and you can flip through those pages utilizing this number here. Let me zoom in. This number right here. So I don't know if you guys noticed that number at all. Let me scroll up to the top of this. You'll see 1 right here. So 1 is going to dictate, it's a command line argument, or not argument, command. It's a command line command that you can give and usher out. All right. 3 is typically going to be for C/C++, and for 2, is that C is, all right, is 2C, 3C++, and there's also a couple other ones. I can't remember what they are all for, but there are, just know there are different pages. All right, and you can cycle through those pages. So I know there's a couple overlapping ones in regards to C and the man page for the actual command line command. I can't remember right now on what that is, what do you call it, or what an example of one is. But if we do the manual for man, you can see here that there is a command that you can use to dictate. Oh, here we go. So 1 is executable or shell commands. 2 is system calls. So these are functions provided by the kernel. This is going to be in a format that's used by C. This is going to be library calls. This is going to be for special files. And then 5 is for file formats. 6 is for games, 7 is for miscellaneous, and then you can see these other ones. So that's what the numbers are used for, and you can switch between the numbers using L. I can't remember right now. Oh, maybe you just put the number at the end. Never mind. You just put the number at the end. So just something to be aware of. Alright, let's move back. I feel like the music got really loud. Turn that down a little bit. Let's go ahead and let me check if there's any questions, and then we'll go ahead and jump on break, because we've been going for quite a bit of time here. Let me see. Alright, doesn't look like there's any other questions. Let's take a 3 to 5 minute break, and let's meet back up, and then we'll go ahead and continue through some more of these commands. We still need to finish up with file, and then we can keep chugging along here. We're almost done with Unix. Don't worry, we're almost done. Alright, I'll see you guys in 3 to 5 minutes. Alrighty, we're back. Magic numbers. Alright, magic. That's what they're called, alright? I was dying to remember what the hell they were called. Alright, magic numbers. They're literally called magic numbers, and these are going to be magic tests, and there's a lot of wizardry going on here, alright? Some Dungeons and Dragons shit up in here, alright? So magic numbers are used to determine what the file is, alright? Alright, before we continue on that, because I was losing my mind. Hey, we're Rootkit. If you're joining us right now, hey, thank you for joining us. If you're coming back, well, hello. It's nice to see you again. We like giving away things for free. We're giving away some more of our sweaters, alright? This week, we are giving our sweaters away, so you can go over to our site, click on blog, and you can see our week 5 giveaway there. Alright, now, if you like what we're doing and you want to help financially support us, you can go over to this link, which I will post in the Twitch and in the YouTube chat, and you can go over there and donate to us. And when you do donate, you can choose certain rewards depending on how much you donated. Also, all donations are being matched 1-for-1 up to the first 10,000. And we have certain pillars that are going on here, like stream for 24 hours straight, shaving off my head here on stream live, and then shaving off my beard, which no one wants to see, so we don't need to get that one, but the other ones would be preferred. Alright, Kote would like a pay raise. Alright, also, if we haven't made it clear, no one in the nonprofit gets paid at all except for Kote. He's the only paid employee, and he barely gets paid what he's supposed to get paid. Alright. Alright, if you're following along with us, we're finishing up Unix right now, going over some final stuff with files and directories. Before moving forward, let me check the chat and see if there were any questions. If you have any questions, you can just drop them anytime. Also, I am in the events chat, so if you are a Patreon or Discord Premium member, you can subscribe there and then hop into the events chat and chat with me. What was the difference between slash and... Oh yeah, good question. So he asked, what's the difference between tilde and the forward slash, right? Tilde is a short link to your home directory, all right? And then the forward slash is the beginning of the hard drive. It's the beginning of your drive, right? This is the root of your drive. So tilde, as you can see, it even, I think, was that a coincidence? Maybe it was, maybe it wasn't, I don't know. But tilde is going to be a reference to this because this is my user's home. All right, this is going to be a reference to the root of the drive. That clear things up? All right, so magic numbers, the things I was showing you guys before, the couple of bytes of information at the beginning of a file that will dictate what that file is. All right, and that's how Linux will go about potentially doing things with it. All right, those are called the magic numbers. All right, so find will analyze those magic numbers and then tell you what the file is. All right, so if we want to do a find on QFC9, sorry, not find, file. If we do a file on QFC9 here, it will say it's a directory, all right? Because it is a directory. And if we were to do our little special hex dump command, which I don't know where it is, so we'll go ahead and type it again. Hex dump QFC9, and then let's get the head of it. All right. Well, I guess it doesn't want to hex dump the directory, but it is a directory. And then if we go into here, we can see our file, and if we do a file on grep my please, that's supposed to say me. Why didn't anyone tell me in the chat? All right, you guys are making me look like a fool out here. You can see that it has identified it's going to be ASCII text. All right. So file will pretty much just tell you the contents of file. It's going to be using the magic numbers at the beginning to kind of figure out what is going on. So you can potentially trick the file command by altering those magic numbers to something else. All right, but that's what file does. Any questions on that? So when I cd, it automatically sends me back to the home directory. Correct. So if you run, so right now if I do pwd, that's our present working directory. All right, so we're currently in the root. All right, if I do an ls, you can see I'm currently in the root. I'm at the topmost level of the hard drive. All right, you can get to your home directory two ways. One, by just doing cd by itself and pressing enter. All right, or you can do tilde. They will both send you the exact same place. Tilde just represents your home directory. The best thing for tilde is you can use it as a absolute path in some cases, because this is getting replaced with behind the scenes home/qfc9. So instead of me wanting, for example, so again, we're at the root directory right now. I want to read the file that we made. All right. To read it here, I would need to give either an absolute or relative path. Let's do an absolute path. I could type in /home/qfc9, and then let's do a double tab here to see what our options is. grep my please. All right. So grep my please, and that will print out the contents. So again, let's clear this. This is the absolute path to it. But we're programmers, we're lazy, all right? So knowing the knowledge that tilde is just a reference to your home directory, we could just remove that beginning part of the absolute path and use tilde instead. Way nicer, way cleaner. And again, this is an absolute path search, but it's just using the tilde as a shortcut so you don't have to type in that original information. So if we press enter again, you'll see it works exactly the same. So it's very nice, very convenient. If you have any more questions, just keep them flowing in. I like them. All right, so let's move on to process-related commands, particularly PS. All right, no association with PlayStation. All right, this is your processes. All right, so if we type in PS, you'll see a list of our current processes that are going on. We do have commands, TAC commands, options that come with it that are very, very useful, right? So PS will report a snapshot of the current processes. So this word snapshot is in reference of these are the current, these are going to be the current processes of when you ran that command. They are not updated live on the command line. There are commands you can run in order to keep it live and like update what's running on your computer, but this is just a snapshot. By default, it's going to be a very limited snapshot. It's only going to show things that the user is currently running, all right? And only like in user, like normal applications that are running. So you can see here we got two that are running. One is bash because we're in a bash terminal right now. And one is PS because when we ran the PS command, we were running the PS command. So that is an active thing that is running on the operating system. We can get more detailed information about what is running if we look at the manual here, and you'll see that there are some extra things here that we can utilize to get extra information. So to see every process on the system using standard syntax, there's some stuff here, etc., etc. And then here is the breakout of the things that you can do. So lots of stuff that you want to do. Typically, when people are running this command, they're going to pair it with tac elf. PS tac elf. So you got a cat on here. You can touch it. You got your good friend Lisa over in LS Town, and you get some elves. Santa's included by default. This thing is fucking off the hinge. All right, this is one wild operating system. All right, go grab your freaking blunt, smoke along with the people making this shit back in the 80s. All right, this was made for you. All right, there's everything you want. Bunch of magical creatures, magic numbers. Hey, what else could you want out of an operating system? Let me just ask you that. All right, so we do pself. All right, this is going to give us a more detailed output of what is running currently. And as you can see, we got a lot more stuff running on our operating system. Again, at the very end here, we're going to see that I ran this command, so it naturally will show up also. We can also see who started this command. So root is the administrator, right? So the admin of the computer itself ran a lot of this initial stuff. And this was starting up the operating system and is how the operating system is running right now. We have some of our own stuff that is running here, like this Docker command, and we have our commands here. You can also see a PID, which is a unique ID. So kind of like the unique IDs files get that we talked about. This is a process ID. So this is a unique ID for every process that is ran, and every single process will have its own unique ID. Additionally, there are parent process IDs. So this is who the parent is, because there's no wild children allowed here, right? You can't make wild children in an operating system, but they are not liked, and they're usually quarantined or destroyed. All right, no one likes wild, crazy children. They are dealt with in an extreme way. All right, so you can see who is the parent of everything by looking at the PPID. All right, so you can see this command right here was launched from 1. So process number 1, which is going to be your operating system, launched this. If we look at our stuff, the parent for this one is 1088. All right, we can look for 1088 and bam, 1088 is going to be the operating system itself. All right, everything is always related to something else, and they're always dependent off of one major parent. All right, the very top line that you see here. So that's how you can see processes are related to each other. This will become more important if we get into multiprocessing and forking, because this is where you'll be able to see this. I don't know how much we're going to get. No, we definitely are going to get into that for this. So when we do go over that, we'll be showing this example off again. So let's go ahead and look at what the ELF options even do in the first place and why they're giving us all this output. So if we scroll down here, we can look for E, select all processes. So it's identical to attack A, which attack A is typically for everything. So E is going to give us everything. E for everything. L and F, let's see, please come up. L and F. There we go. F is going to do a full format listing. So this is where you're going to get a lot more options here. Let's see if it lists all of them. This option can be combined with many other Unix style options to add additional columns. It also causes the command arguments to be printed when used with tag L, the number of threads. Do full. Okay, well, this allows you to do full format listings. It doesn't get like say exactly what here. And then let's look for L. L is going to be displaying BSD long format. So let's see anything else here that would be useful. Setting the columns might be useful. There should also be, was that the right L? Think so. There's also more information that you can get from this command to help out with these columns right here. Let's see here. So this can be very useful for seeing what's going on. It's the equivalent of having Task Manager up and seeing Task Manager, or seeing specifically each process and what their ID is. So the equivalent to that in DOS would be the task list. Is that going to work on this one? Yeah. And then you get the exact same equivalency here. All right. Now, if you do want a live view of stuff, and this is not on the test, you can do top. Top is going to be basically the PS command, but this is going to be live. So as you can see, things aren't really changing too much. If you look here, you'll notice that there are some stuff changing, like idle is changing right here, because we're not really doing much on the computer, but this one is live. So unlike PS, that's why it says the word snapshot. Any questions in regards to that? Could you do it a little slower, please? How do I quit the cat command? So if you cat something that is very, very large, do Control C. Remember, Control C is our homebrewed cancel culture built in a computer. If you want to cancel something, Control C it. All right, Control C is the forcefully cancel something, and it works in most cases. All right, so go out there and go cancel something today. All right, everyone's doing it. It's the most popular thing out there right now. All right, so along with processes, we need to know how to kill those pesky ones. All right, like little gnats or mosquitoes. Just gotta squash them, get them out of here. All right, especially if they're stray children or orphan children, as we call them here in the computer science world. We kill orphan children's. All right, don't take this, don't clip that and put it out of context. All right, but in computer science, we kill off orphan children. All right, they're no good to us. So how you go about killing things, there are two ways. You can use the kill command. All right, kill is how you can kill something in particular. And there's also its companion, pkill. All right, so if we press Q, there's also pkill. So kill and pkill. All right, pkill by default will be looking things up by its process name. Can I? Oh, whoops! I keep trying to scroll. And then kill is going to be using the PID. All right, you can see here your PID is going to be what you give it. Again, this is not in brackets, which means it's required. So to kill something, you need to say it's PID, and for pkill, what's required here is some type of pattern. So from our find command, we could potentially infer. It may work without dictating what pattern we're using, but this may be a time where you can infer and be like, it may want me to actually declare what pattern we should be using. All right, so you can look through here and figure out exactly how you can go about it. pkill is also useful for killing an entire user's account or things that users are running. So it could be better as an administrator thing. So for example, if someone is, taking up all the resources on a box, maybe they're trying to DOS you or something, you can pkill their entire session and get them off the box. So let's go ahead and maybe run something. Let's run something and then kill it. All right, we'll kill it with fire. Let's go and cd into our home directory here, and let's run something like nano, and we'll run it in the background. There we go. So to run something in the background, you can use the ampersand. I almost said Amsterdam. The ampersand sign at the end of it to run in the background. When we do that, it will give us the PID of it. So it has a PID of 1778. We can also look by doing our ps tag elf, and our elf friends will tell us right here that this has a PID of 1778. And if you want to know what it is, look at the very end here where it says command, and it will tell you right here, nano grepmy, and it didn't finish, but that is the current process that is running. All right, we are currently not in that process. Oh no, it's ran away from us. We want to kill it with fire. All right, because we have no control over it anymore, and we want to have control. We desire control. All right, let's move on here. So we can kill it with fire. If you say kill and then put in the PID, so 1778, and press enter, nothing printed out, which means it worked. It is now killed. If we rerun the PS command, you'll see that the command is still there. It is not killed with fire. And that's okay. That happens sometimes. So instead of killing it with fire, you need to kill it with a nuclear bomb. So I'll show you guys how to bring out the nuclear bomb. All right? How you can really make sure something is dead. All right? Any questions so far? All right. How we can make sure we nuke the shit out of something if we really don't want it and it's pissing us off and it's really annoying is there are severity levels to how much you really want to destroy something. All right. So if we take a look at the man page for kill, let's see. So we got this. Where is it? It doesn't really go into much, but we got one special thing here, and well, we don't want to do it with that. That's killing everything possible. Basically, we can signify signals. All right. Signals are special things you can send on a computer to signalize something has happened, gone wrong, is restarting. There's a whole list of signals. So this is where something like the actual website may be better than the man pages here because you can't click anything or find any more information about signals. You can if you read right here, it says signals, page 7 of signals. We can learn more about it. So if we want to do that the manual way, if we type in man signals, and this is where it did bring us to page 7 by default. So if it didn't bring you to the page you were supposed to go to by default, you can do a space and then signify what page you want to go to. So we want to go to page 7. So this will give us an overview of different signals that you can send on an operating system. All right. So you'll see here there are various different signals. This is using signals. Is this going to list them? Oh, here we go. So these are the various different signals that you can utilize in your operating system, and there's a whole list of them. In particular, where is the one I'm looking for? Right here. Sig-kill is the most hardcore one. All right, so this is going to be something that we can utilize in order to forcefully kill stuff. This doc is not very good because it does not run you through. Oh, I spoke too soon. Here we go. Here are the numbers associated with each one of them. All right, so you can choose which one is most appropriate to you. By default, I believe sig-quit is what's given to it's what's ushered to a process to kill it nicely. All right, it's kind of like a, hey buddy, it's time to walk the plank. All right, it's time to jump off the side of the ship. You're not wanted anymore. There are different levels and things you can use these signals for. The most severe one, the nuke option, is going to be 9. All right, so there's lots of memes in the computer science space realm in regards to kill TAC9. All right. The dash is usually referred to as attack. So if you can't kill something and it won't die initially, you can kill TAC9 it. All right, that is the most severe way you can murder something and just absolutely destroy it off your box. So let's go ahead and do a kill TAC9. And now that we've forcefully nuked it, let's go ahead and look here again, and it is gone. It has been absolutely destroyed. All right. Again, right here, it was still existent, never went away when we did kill normally. So we wanted to nuke the shit out of it. And when we did, look at that. It is completely gone now. It is no longer here. Kill TAC9. Kill TAC9. Kill TAC9. It works in P-kill also. TAC9 shit. I've said it like 20 times already. Knock on wood. It's going to be on the test. TAC9, all right? It's going to be important to your career. You're going to need to know this because you're going to use it a lot, more commonly than you would think. You would think things would be more graceful or would handle the like subtle nice signal of, hey, it's time to close up shop, get out of here, buddy. but a lot of things don't. So kill Tac9 is going to be your way to forcefully end a relationship with another process. All right. Alrighty. Any questions on that? So let's move on to some other helpful commands. All right. So we have the strings command. Strings is going to be built in by default in most operating systems, and it can be very, very useful. Particularly if you want to search through things. It's another way to print out, but only to print out text. So if we use this on something like our file here, strings grepping our text file, you don't really see the benefit here. All right, it's only beneficial when we get to our binary files. So if we cd to our bin directory here and we look at our programs here, like maybe move, if we do strings move, look at that, we get a printout of a bunch of text that was found in this command. Where this really comes helpful, we'll see some examples here in a second. I see some questions. It's frozen. I cannot scroll up or down in commands. For the cat command, I'm not quite sure what's going on for you, but I would recommend just, if you're really stuck, closing and then reconnecting to a new terminal session. That is always the last hope. So go ahead and do that. All right. So, strings. It will go through files that have unreadable text in them, so stuff like binary data, and it will ignore it and grab all of the readable data out of it and print it out to the screen for you. All right, this can be potentially useful for several different tasks that you want to do in regards to making binary files, making sure things are coming through properly. It can also be used for exploitation, all right? So if I use something like strings on a video game and I want to find some secret hidden key that's in there, don't put it in plain text. You can easily view plain text and see what's going on. I can run a strings command and find the passwords for things or other credentials that may be important. Do not leave things in your executables as plain text, right? Just because they are an executable does not mean everything in there is converted to binary. A lot of it remains in the normal text format. Again, anything you give to a user, expect it to be potentially exploited, either on mistake or on purpose. So be careful. Use strings to help secure your applications if you need to. If we do a normal cat on the move, and I'm going to just print out the head of it because I don't want a bunch of this. This is what it normally looks like. You'll see there is some text in here that is readable, but it's mixed between a bunch of binary data. All right, bunch of binary data, some craziness. So we can use strings to ignore all of that. So if I do strings move, and we'll just get the head of it, you'll see I can ignore all that craziness and just get the text that's in there, that's publicly exposed. So could be potentially a useful program for you. All right, so let's say you ran a bunch of commands and it was like 100 commands ago and you can't remember what it was. And you're clicking the up arrow key right here and you're searching for it and you're searching for it. You just cannot find it for the life of you. Or maybe it's just super far back and you don't want to sit there scrolling through forever to find this command. Don't worry. Everything you do is being logged. They're always watching you. All right? There's no way to avoid it. So just get used to it. All right? Just make partners. All right? I've already built a statue of the Google gods. All right, I send my offerings all the time to keep things at peace between them and me. All right, sometimes you can't beat them, man. Just gotta join them. All right, they're always, everything you do on the operating system is being logged in regards to what you're typing in, unless you change the settings for that. How you can tap into that ultimate power is using the history command. If you want to view your history, all right, and delete all the naughty bits, history, all right, history. If you type in history, that will show you the history of all the commands you have ran. So we can see here that I've ran a lot of commands, 449 different commands on this, what do you call it? On Ubuntu here, since I've created it. And you can search through all of them. And now you can try to more easily find the command that you ran earlier that was successful. Where things really get more powerful, again, we talked about pipe and how to do some good old piping back in DOS, all right? You can still use pipe, and you've seen me use pipe several times already inside of Unix-like operating systems, all right? What will pipe do? Again, pipe will take the output from the first command and throw it into the input of the second command, all right? So when you do things like head here, I can just get the first little bit of information. So if I do, let's do this one, let's do tail, all right? Because I only want the tail end of everything. So if I do tail, I'll get the last 10 pieces of output. That can be potentially very useful for you. What also can be very useful for you is if you pipe it into something like grep and you want to search for something specific, like the su command that maybe I ran before. And now I can get an output of all the su commands that I ran or things that match with su and find things really easily. So this is where piping gets really, really powerful for other commands that you've learned, and then also you got your history that you can look through if you need to find something that you did and you can't remember what it was. Any questions on that? And if we look at the man page for history, is there any TAC options? It doesn't look, by default, I don't see anything here for TAC options. So I'm going to assume there isn't any. It looks like there may be. I don't know. You're free to look through the man page and figure it out. But let us move forward. The script command. So scripts, make type of terminal session. Scripts will allow you to make scripts in your terminal here. It's kind of like the what do you call it? I'm blanking on things. The macros over in PowerShell land. All right, let me pull up my notes real quick. Come on. All right. Not much too useful for this, but effectively if you make so even though PowerShell is like designed for scripting, you can make automation scripts in DOS and in Bash, in Unix, using Bash scripts. All right. Now in DOS, they're going to be called .bat files. So if you ever see a .bat file, that's going to be a DOS-based script. Don't run them if you download on the internet. That's a no-no. Don't really run bat files unless you know what you're doing. Usually bad things will come with that. That's half true for the Linux world also. Don't just go running any script. So if you want to execute scripts inside of your bash host, so if you want bash scripts, so let's say there's like 10 commands you want to auto run. All right, you can do that. You can write a file, put all the commands in there, and execute it. All right, there's several ways you can execute it. You can execute it using the script command. All right, and then afterwards you'll put the script that you made, or you can execute it doing a /, which we'll get into more when we start programming in Python. Maybe we can show it right now, actually. Let's go ahead and make our own script right now. So let's say vim my script All right, so let's go ahead and make a script here, and we're gonna go ahead and I'm pretty sure I'm gonna need to put the header. I don't know, let's run it without the header. Let's go ahead and just make this do the ls command and then echo I'm done. And let's do at the beginning echo start script hacking. All right. Exit. All right, sweet. So we got the script, and we can use the script command to execute this script. And so you can see the script has started, and it is logging. It is putting stuff into output log file is my script. Did it really? Oh no, this bastard. It overwrit my thing. So it logged it out. So the thing for a script is it's going to automatically run things in the background, nice and nice for you, so you don't have to see anything. But it's going to, or did it put it in var? I don't use the scripts, the script functionality very much. Usually you'll be just executing directly, but that's a way you can go about doing it. All right, I don't know why, but it's my script. It overwrote my script, but there was a log output somewhere. Hopefully it didn't just do that for no reason, but we shall move on. I'll show you guys how you typically invoke your own scripts here in a little bit when we get to the file perm stuff. All right, so there's going to be Sue, a boy named Sue. All right, man Sue. All right, so Sue, what the heck is going on here? My computer is freaking out. All right, here we go. Sue. Sue is how you can switch users. All right, SU, switch users. All right, this is how you can switch a user, or you can temporarily run a command as a user if you would like also. Right, it lets you do either or. Typically it's most used with switching users, so you could switch users and log into another user account if you wanted, like root. All right, it's gonna ask for the password, and I can log into root. All right, so early on in the stream you saw me use sudo su because you can't just do, if memory works correctly, you can't just do su root. Did I do the password wrong? Can't remember. Whatever. Because you're going to a account with higher privs, so typically you'll need to sudo su. Also sudo su, since it is at an admin level, will auto let you mimic users, because when you're an admin you have god tier stats, which means you can just become anyone else at any time, no questions asked. All right, so su is for switching users or posing as a user, the poser command. So sudo, we've been using this sudo every once in a while. What does sudo mean? What does it do? What does the man page say for sudo? That's a great question. So sudo is execute a command as another user, not usually as another user, usually as the admin account. You are getting temporary full admin permissions, full god tier perms to execute or run something. All right, so it is the creme de la creme, the highest of the highest perms that you're able to have. All right, the only higher ones would be actually being the administrator account, but sudo lets you temporarily run something as the administrator account. So sometimes you may need to sudo kill a process. Even if tac9 doesn't work, technically there's one more option above tac9. All right, if tac9 is a nuclear bomb, all right, then sudo kill tac9 is going to be the biggest hydrogen bomb in the world. I don't know. That's all the way up at the top level of killing things. All right, but sudo is how you can temporarily become an admin. This can be beneficial when you want to do things. For example, let's say we want to list the contents or list the contents of etc past WD. All right, that one works. Sorry, etc shadow. All right, I don't have perms here. The only people that have perms for this are going to be the administrator account, and we can kind of see that when we get into our perm section. We'll bring that more around when we talk about the perm section. But sudo, if I ran it with sudo, it would allow me to do it if I'm allowed to temporarily act like the administrator, right? If you're on a corporate system, you may not always have access to sudo because that's a lot of power. And with great power comes great responsibility, all right? So usually people aren't going to trust you with all that power unless you need it. Luckily for you, if you're running things on your own box, you can just have all that power because you granted yourself access to the computer. All right. You can also revoke yourself power if you want to also. Let's see. Any questions so far? Do sudo install voice to run a VM script. Yep. Sometimes you will have to do that. Usually when you ever install any updates on your box, you will run it as a sudo command because you'll need root permissions to do updates. So we got these things called, I guess we'll end it after we go over these commands, and we'll continue tomorrow finishing up, we're diving into 6 and then 7. This is going a little bit longer than I thought it would. So let's go ahead and finish this up quickly. So there's gzip and gunzip. All right, gzip is how you can zip up and you can compress and uncompress files. So zip them up and unzip them. All right. So the options that are going to be most important for the zipping up and unzipping are going to be, let me see if I can find them all. Let me just refer to my notes. And of course, I don't have them on my notes. You have to explicitly specify whether you're performing a zip or unzip operation. Here we go. D is for unzip. All right, and you can see there's more options here in regards to zipping. You can also list the contents inside a file without actually uncompressing it, which is really, really nice. Typically, you'll see these files with a .gz at the end of them. All right, so gzip and gunzip are going to be exactly the same. One's just the longer form version. The other one's the shorter form version. Let's see. Yeah, you can see all these are going to be doing the same. They're going to have the same commands. Here's all the options for them. Typically, when you need to compress or uncompress something, you'll see they'll come paired with the options that you need to execute along with them. I do not know why I'm seeing them. Maybe it was in the example section. I'm just breezing through everything too quick. Was it CD? So they got some examples here that you can utilize. So compress. So C is going to be for zipping things up. And then E is going to be for extracting. But yeah, it's built-in zip functionality that you can utilize. All right, very, very useful. And then the final one, which is more common, should I say more common? It's pretty common to see gzip paired with tarring. Tar is another way you can archive files. So if we look at tar, it's for archiving. So this will allow you to also compress things a little bit further. So you can zip up things multiple times to really compress it. Tar is your built-in basically for the Unix equivalent for backing things up. This is how you can archive and back up copies of your data and everything that you're doing. It's pre-built into the operating system, and this is how you'd be going about utilizing it. Tar is a little bit weird at first for most new users because it will not work out of the bat with just saying tar. You're going to need to run the tat commands with them. And will this have... So right here are some of the tat commands. So this is going to be for compressing your data together. And you're going to see that C is going to be for creating an archive. V is going to be verbosely printing things out onto the screen so you can visually see what's being archived. Not required. It's just an option that you can do. And F is going to be reading or writing from a file. All right. And then to uncompress things, you're going to need X. So you basically swap out the C for an X, and then that's how you can now do your uncompression. All right. So gzip, also known as gunzip, and then tar are two ways you can zip up files. Usually they're done one after each other. So someone will zip something and then they'll tar it on top of it to make it even smaller, and it's easier for archival storage. Any questions on that? The tat commands that you're going to need to know for both of them is how to extract stuff, how you can create in a compression, how you can save it to a file, and how to verbosely print things out. All right. Any questions on that? We went over a lot of stuff today. Another full day full of content. Tomorrow we'll finish up most of Unix with the file and directory permission stuff here. This will be very important. And then we'll talk about mobile operating systems for a little bit. So it should be a little bit of a lighter day tomorrow. Any questions on anything we went over before we conclude today? No? All right, sweet. I shall see you guys. Thank you guys for, chilling, watching, for all your guys' questions and input. It's super awesome. Makes it more interactive. I like it. I wish we had some of the quizzing and functionality and stuff up and running, but we're kind of busy with Project 26 stuff right now. So when we redo this 100 Days of Rootkit, potentially later this year, next year, we will have a lot more functionality and fun stuff, interactiveness, particularly on some of the streams, like things you can do to like answer questions and get points and so forth. So it'll be fun. It'll be fun. All right. That's all I got for you guys today. I shall see you guys on the next one.